Welcome to this session on CCNA tutorial, Network Fundamentals. This video is aligned with Cisco's official CCNA exam blueprint and is designed to guide you step by step towards certification success. Today we'll be covering section 1.4, Identify Interface and Cable Issues. In this section, we focus on identifying interface and cable issues, some of the most common problems you'll face in real networks and on the CCNA exam. You'll learn how to recognize collisions, CRC errors, runts, giants, duplex mismatches, and speed issues. We'll also cover how to read show interfaces output so you can quickly spot anomalies. These counters and messages provide key clues about what's really happening at Layer 1 and Layer 2. By the end of this lesson, you'll know not only how to spot the problem, but also how to resolve it. Collisions occur when two Ethernet devices transmit at the same time on the same medium. This was common in legacy hub-based or half-duplex networks, but should never happen in modern full-duplex switched Ethernet. Collisions happen because multiple devices compete for the same collision domain, and CSMA/CD has to stop and retransmit after a random delay. You'll know there's a problem if collision counters in show interfaces increase, performance slows down, or retransmissions become frequent. A healthy full duplex link should show 0 collisions. If collisions appear, the solution is to eliminate hubs, configure full duplex correctly, or replace faulty NICs. Errors represent abnormal frames that violate Ethernet standards. A CRC error means the checksum failed, showing corruption in transit. Runts are frames smaller than 64 bytes, often caused by collisions or duplex mismatches. Giants are frames larger than 1,518 bytes, usually due to MTU mismatches or faulty NICs. You'll see these as input errors in show interfaces. If CRC, runts, or giants increase, expect packet loss and poor throughput. A clean interface should always report 0. Fixes include replacing or rerouting bad cabling, reducing EMI interference, correcting MTU settings, and checking duplex consistency. A duplex mismatch happens when one side of a link runs full duplex, while the other side is half duplex. This typically occurs when one end is hard-coded and the other is left to auto-negotiate. Auto-negotiation defaults to half duplex if it can't detect partner settings, causing the mismatch. The result is very slow throughput, CRC errors, and late collisions. Cisco devices often warn you with a duplex mismatch message. In show interfaces, you'll spot half duplex paired with errors. The fix is to configure both ends consistently. Ideally, use auto-negotiation on both or hard set both ends the same. Speed mismatches occur when two ends of a link are configured with different speeds. For example, one end forced to 100 megabits per second and the other on auto. Or, one device only supports fast Ethernet while the other is gigabit. When speeds don't align, the link may fail to come up at all, flap repeatedly, or run very poorly. In show interfaces, you'll see line protocol down if the speeds don't match. To resolve, make sure both ends use the same speed, or better yet, leave both set to auto. Also confirm hardware supports the desired speed. Here you can see a summary of what we've already covered, so just use it as a quick reference during review. The exam will often give you a snippet of show interfaces and ask you to identify the problem based on these counters. The key rule is on a healthy link, these counters are always 0. Any increase means something is wrong, and the type of counter tells you exactly where to look. When scanning show interfaces in the exam, use a fast checklist. First, check the interface status. Is it up/up? Next, verify duplex and speed. Then scan for non-zero counters, like collisions, CRCs, runts, giants, or late collisions. Confirm that reliability is at 255 out of 255. Finally, check for drops or resets. If any of these fields don't match the expected healthy values, you've found the anomaly. That's exactly what the CCNA exam is testing: your ability to spot what stands out in a long iOS output. We've covered collisions, errors, duplex mismatches, and speed issues. Together, these represent the most common physical and data link layer problems you'll troubleshoot as a network engineer. In the CCNA exam, expect to see these as practical iOS outputs where you'll need to identify the anomaly. Before moving on, review the slides, test yourself with the quizzes, and make sure you can quickly scan a show interfaces output to pick out the error. Once you're confident, you'll be ready for the next section, comparing TCP and UDP.